This interactive schematic on Teknic's website shows an example IP67 sealed ClearPath MC servo system with accessories, required and optional. If you're setting up a ClearPath MC system for the first time, we recommend going through this accessories guide step by step. If you want info on one specific category of accessories, you can click on the schematic to jump right to that section of the guide. This text will give you a general explanation of the category, and you can click on a specific accessory to get more detail, like drawings and 3D models, and add the item to your cart. A check mark will appear in the menu for the category after you've added one or more items to your cart. If you want to learn exactly what accessories you will need or want for your ClearPath project, keep watching. We'll discuss each accessory, starting with the main bus power supply. You can use your own power supply or get one from Teknic. ClearPath fractional horsepower motors will run from 24 to 75 volts DC, but we usually recommend using 75 volts because more voltage gives you more power for the same amount of current, which usually means smaller motors for any given application, saving space and money. Teknic's IPC 75 volt power supplies have been designed for the unique power requirements of motor drives. Among these, high peak power reserve and the ability to handle regenerated energy. The IPC supplies are available in both a lower power open chassis design and a higher power fully enclosed design. Compared to the open chassis model, the fully enclosed IPC supply has more continuous power, more ability to absorb a motor's regenerated energy, and a finger-safe enclosure to protect against electrical shock and physical damage. The amount of electrical power you need for a ClearPath-driven machine is highly dependent on the exact application and the motor quantities and their sizes. So it's almost impossible to say exactly how much supply power you need for a given application, but here are some helpful hints. From the higher power enclosed supply, you can always run at least one NEMA 23 or NEMA 34 ClearPath motor of any length in any application. And from the lower power open chassis supply, you can almost always run one ClearPath motor of most sizes in most applications. That said, you can usually run any two motors from the higher power supply and two smaller motors from the lower power supply. In machines with smaller motors, and when the motors are used intermittently and/or not at the same time, it's possible to run 4 motors, or even more in certain cases, from the lower power supply, or 6 or more from the higher power supply. Given the large number of variables in a multi-axis machine, you'll have to test thoroughly to see how many motors you can reliably connect to one supply. But remember that by the laws of thermodynamics, you can't get more, or even the same, mechanical power out of the motors than the DC electrical power you put in. Both supplies can be run from single-phase 95 to 125 volts AC, or single-phase 190 to 250 volts AC, 50 to 60 hertz. For people who want to run off the lower AC voltage range, common when you're first experimenting with a motor at your desk or bench, we offer a pre-wired AC line cable. This cable has an 8-pin Molex MiniFit Junior connector on one end and a standard US 120-volt 3-prong AC plug on the other. If you want to run off the higher line voltage, you can cut off the 3-prong connector and rewire it to your desired high-voltage connector. But you must make sure to remove or cut the jumper wire in the Molex connector, or you will damage the power supply. Exactly which supply you'll use in your application will depend on your mechanical power requirements and whether the power supply will be mounted inside the machine's enclosure. When you're developing your machine, however, we recommend you use the fully enclosed supply for maximum power and safety. Teknic offers 2 easy ways to distribute power to each motor. One solution includes logic power backup capability, and one does not. The logic power backup feature allows you to remove main bus power from the motors to prevent any motion while still providing logic power. If DC bus power is interrupted, let's say because your machine cuts hazardous AC power upon an emergency stop, The hub will continue to keep the motor's processor awake. When bus power is restored, each axis will automatically move at a user-defined speed to its proper position. By connecting bus power and logic power to this hub, you can distribute both using a single power cable per motor to up to 4 motors per hub. You can daisy chain 2 boards together to distribute power to as many as 8 motors, assuming your power supply has the capacity. Note that with this distribution board, you must connect power to both the bus and logic connectors. For this power hub, you'll need these 3 components. First, a cable to connect your bus power supply to the power distribution board. It's plug and play with a Teknic IPC power supply, but if you're using a different bus supply, you'll probably need to change the connector on one end. And a cable to connect your logic power supply, which can be from 12 to 75 volts DC. This low-cost 24-volt power supply can easily provide logic power for at least a few dozen motors. If you want to retain logic power even after a loss of all power to your machine, you can use a 12-volt battery and charger as a backup power supply and get days of backup capacity. This gives you almost all the benefits of having a multi-turn absolute encoder on every motor without the high cost. And with only one battery per machine versus a battery in every drive, maintenance is easy. In applications where there's no need to recover position after cutting power, this distribution board makes it easy to run the motor's logic circuits with the same power supply you use for bus power, so you only need one power cable per motor. The second bus power connector can be used to daisy chain 2 boards together to distribute power to as many as 8 motors, assuming your power supply has the capacity. If you want to make either of the cables that go to the hub yourself, the tools and components are readily available online, from DigiKey for example. All part numbers can be found in the user manual. Just be sure to use the proper tools, or you'll end up with unreliable cables. If your application has only 1 or 2 axes, it is possible to make do without a power distribution accessory, but it requires you to custom build a Y-shaped cable, so it's rarely worthwhile given the low cost of a power distribution board. Next, you need a motor power cable to connect each motor to the power distribution board. Teknic motor power cables come in 2 different lengths, a 10-foot and a 55-foot. The length is not the only difference. The 10-foot DC power cable has an M12 K-code connector, overmolded to be dust and waterproof, on the end that connects to the motor. And on the other end, it has a 4-pin Molex minifit connector that plugs directly into a Teknic power distribution board. If you want to shorten this 10-foot cable, cut off and rebuild the Molex end. Do not attempt to hand terminate an M12 connector. The 55-foot cable is long enough for just about any application, but because it's so long, we expect that most people will cut it down to exactly the length they need. That's why we put M12 K-code overmolded motor connectors on both ends. So after you cut it, you'll end up with a second cable of the remaining length for free. Of course, you'll need to terminate the cut end with a Molex minifit connector to plug it into your power distribution board. ClearPath motors natively use digital control signals for best noise immunity, but some applications still use analog control signals. Click here to show 2 options for using analog control signals with ClearPath MC, Teknic's ClearCore Motion and I/O controller, or the ASU Analog Send Unit. The Analog Send Unit, ASU-FR510, converts 0 to 10 volt or 4 to 20 milliamp analog signals into a noise-immune digital command that can be transmitted longer distances without fear of noise corruption. The ASU goes in between your control signals and ClearPath, so instead of 1 controller cable, you'll want 2. You'll also need an analog signal cable and a DC power cable for 24-volt power. So to get continuously variable control of a ClearPath motor using analog signals, use an ASU-FR510 analog send unit along with 2 controller cables, 1 analog I/O cable, and a power cable to connect to your 24-volt power source. Teknic's ClearCore controller has 4 analog inputs, so it's a more flexible and powerful alternative for handling analog signals. If you use ClearCore, you won't need the analog I/O cable because ClearCore uses screw terminal connectors. You'll just need some wire and a bag of the terminal block plugs. The next cable is the controller cable. It connects ClearPath to your digital control signals, or Teknic's ClearCore, I/O, and motion controllers. Teknic offers two controller cable options to choose from. The first is a 10-foot cable. The motor end has an M12 A-code connector, overmolded to be dust and waterproof. The controller end has an 8-pin overmolded Molex MiniFit Junior connector that's plug and play with Teknic's motion controllers. Or you can cut it off to connect individual wires to your control signals. The 55-foot cable has overmolded M12 connectors on both ends, allowing you to cut it into two cables, each with an overmolded connector at the motor end. If you want to connect to a Teknic ClearCore controller, you'll find the components and tools you need to terminate the cut end with the appropriate connector in the controller's user manual. If you have a vertical axis that will fall if the servo motor disengages, you'll probably want to order a power-off brake. These brakes mount to the front flange of the motor and allow motion as long as 24 volts is applied. If this power is cut, either by brake control logic or a power loss, an internal spring forces the brake discs to lock the motor shaft, preventing motion. Now with all the power and wiring taken care of, let's look at how you'll set up the motor for your application. The initial setup and tuning of your ClearPath servo is done via USB over a waterproof infrared link. The USB to infrared communications converter is only needed during setup and is then disconnected from the motor. The IR converter has 3 USB-C inputs, so you can conveniently connect to the motor from 3 different directions. The magnetic attachment allows a safe breakaway from the motor in case the cable gets accidentally yanked. By default, when you click the Add to Cart button, you will add both the IR converter and a 3-meter-long data quality USB-C cable. If you already have a long data quality USB-C cable, type a 0 into the quantity box before pressing Add to Cart. If your motor environment is particularly dirty, you can cover the IR port to help keep it clean. Even without the cover, all ClearPath servos with this IR port are fully IP67 and IP66K waterproof. The cover just helps prevent any accumulation of dirt on the sealed IR port. Finally, download a free copy of the ClearPath MSP software. This will allow you to set up and auto-tune your ClearPath servo system. There's a component you might want to add, but probably shouldn't: a shaft key. Mechanisms are sometimes coupled to motor shafts with a combination of a shaft key and a set screw. This sort of fastening is marginally okay for single-direction constant velocity applications, but with ClearPath's ability to start, stop, and reverse with high power and precision, you'll want something better. After years of seeing every fastening method under the sun, we've determined that the best overall solution for a servo system is the clamp-style coupling. If you can't find your desired component, for example a timing pulley, with a built-in clamp coupling, the next best option is to use Loctite retaining adhesive for cylindrical components. Used properly, it holds extremely well, and components can still be easily removed with a heat gun. Visit this URL for a thorough article on how to properly couple a mechanism to a motor shaft. There's a link in the description as well.